If a car is traveling at 70 kilometers per hour as the traffic light turns yellow and it is 3 seconds before it turns red, how close to the light does the car have to be to make it through the light? So we're going to start off by changing it from kilometers per hour to meters per second. To do that, we're going to do dimensional analysis. 70 kilometers per hour and 1 hour equals 60 minutes. 1 minute equals 60 seconds. So we got the seconds part. Now we're going to find the meters. 1 kilometer equals 1,000 meters. Now to plug that into your calculator, you would get 19.44 meters per second, which is the units that we want to use. Now we're going to find the displacement using the displacement formula. So it's going to be x equals v of I times t plus 1/2 acceleration times squared. So we don't know what the x is, so we're going to leave that as that. Our velocity initial is what we just solved for, so it's 19.44, and our time is 3 seconds. 1/2. Our acceleration is 0 because he's not accelerating. And then our time is 3. We're going to square that. So once you plug that into the calculator, you get 58.3 meters. And that is how close you would have to be to the light to be able to make it through. Now the second part of the equation is a second car going 55 kilometers per hour, traveling perpendicular to the first car, crosses the stop line, which is 15 meters from the center of the intersection at a constant velocity. How close do the two cars come? So to solve that, we are going to, again, change it from kilometers per hour. So we're going to do 55 kilometers per hour and use dimensional analysis again. 1 hour equals 60 minutes. 1 minute equals 60 seconds. So we found the seconds part. Now we're going to do 1 kilometer equals 1,000 meters. And so once you do that out, it's going to be 15.28 meters per second. So now we're going to do our unknowns and unknowns for this equation. So we know that V of A, which is the first car, is 19.44 meters per second. And then V of B, which we just found using dimensional analysis, is 15.28 meters per second. And we also know that the distance for B is x of B equals 15 meters. So we don't know time, and we don't know x of A. So that's what we have to find. We're going to start by finding time by using this equation. X final equals x initial plus v times t. And so we're going to plug 15 in. So 15 equals 0 because it starts at 0, plus our velocity, which we found was 15.28 times time. So we're going to divide by 15.28 to find the time. So the time equals 0.98 seconds. Now we're going to find x of A, and to do that we're going to use the same equation, just solve it differently. So x of A equals x of I, which that is still 0, so we'll just cross that out. And it's going to be, the velocity is 19.44 times the time we found above, and I'm just going to use t there. And so x of a comes out to be 19.05 meters. And that is how you solve that problem.